In this video, we'll start into the idea of a direct proof by first asking ourselves, what does it take to verify, to show, or to prove a universally or existentially quantified statement? So remember, if I have a universally quantified statement like for all x in S, R of x, this means, if this is true, this means that every element of S, R of x, is true. And so what does it take to prove this? Well, if my set S it has just finitely many elements, like we have down here in the example, all I have to do is just show that R of x is true for every single one of these elements of S. And for an existentially quantified statement, I just have to show that R of x is true for at least one of these elements of S. And so in either case, let's take this example here, and let's look at the value, the truth value of R of x for every element of S. So let's do that, and let's see if the universally quantified statement or the existentially quantified statement are true in this case. And in general, neither of these have to be true, right? Neither are true if R of x is false for every possible value. But let's just look at this. So I can examine R of 3. So that would be 3 squared plus 5 times 3 plus 4 over 2 is even. 3 squared plus 5 times 3, so that's 9, plus 15, that's 24. 28 over 2, that's 14. So this is equivalent to 14 is even, which is true. So R of 3 is true. Let's look at R of 4, our next element in this set. That would be 4 squared plus 5 times 4 plus 4 over 2 is even. 4 squared is 16 plus 20, so that's 36, plus 4, that's 40 over 2, that's 20. So this is equivalent to the statement 20 is even. That's also true. So going well so far. Let's take a look at R of 5. R of 5 is 5 squared plus 5 times 5 plus 4 over 2 is even. And that'd be equivalent to 25 plus 25, that's 50, plus 4 is 54 over 2. Wait, I've done something wrong there, right? This one should be false. 5 squared is 25. Plus another 25, that's 50, plus 4, that's 54. Right, no, 54 over 2, right, so 54 over 2 is 27. Yeah, I don't know what I was thinking, I wasn't dividing by 2 properly. Is equivalent to the statement 27 is even, and that is false. So, again, the point of this is to identify whether the universal statement or the existentially quantified statement is true or false. So let's see. Since R of 5 was false, it's not the case that every element of S R of x. So the statement for all x in S, R of x is false because R of 5 was false. So that one's false. What about the existentially quantified statement? There exists x and S such that R of x. Well, yeah, there is at least one value of S such that R of x is true. Because, well, for instance, R of 4 is true. Well, we could also use the justification that R of 3 was true, and that would also make this true. So here the universally quantified statement is false because at least one of them gave me a false truth value, but the existentially quantified statement was true because at least one of these gave me a true value. Okay, so yeah, in this case, when S is a finite set like this is really all we have to do to prove a statement like this. That's really all you have to do. Like I could we would have a proof of this statement by just finding R of 4 and showing that that's true. That would prove this statement, and I could prove this one by false by providing this example 5. R of 5 gave me a false statement. So in the next video, we're going to talk about, in general, when I have just a general set that could be infinite, how do I prove a statement, a universally quantified statement or existentially quantified statement is true? How do I actually do that if I can't just look at every single element, right? If I can't just do all of the examples. In that case, we're going to have to use logic, we're going to have to use definitions and assumptions, other theorems, axioms, to prove that the statement is true. All right, we'll look at that in the next video.